Let's begin. Today's October 10th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 3, 8, 18, 19, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A takes a look at our middle digit, the square digit, and compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B will take a look at our 3-digit solution and will let us know how many of those digits are 1. Is there a single one? Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card C will take our 3 digits, triangle, square, and circle, add them up, and the Turing machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D takes our first 2 digits, triangle and square, adds them up, and compares it to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will again take a look at our 3-digit solution, but this time it'll tell us a little bit about its structure, so to speak. There are 2 possibilities. Either you do have a pair in the solution, as in the example 131, or the solution has no pairs. But there are 2 scenarios. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that one unique 3-digit solution that abides by all of the 5 criteria cards we've just described. And we're going to start off with an initial proposal of 314. So I think the first thing I want to test is criteria card C. Okay, so in criteria card C, we're adding up all the digits, so let's go ahead and do that with my proposal. So 3 plus 1 is 4, and 4 plus 4 is 8. That sum total is an even quantity, but the Turing machine does not approve of that. So basically, it's letting us know that the sum of the 3 digits should actually be a sum total of an odd quantity. So let's go ahead and type that up in our notes in section C. And that again is that triangle plus square plus circle should be odd. Okay, so what does that let us know if the sum total should be an odd quantity? Well, there are a couple of scenarios. You could have an all-odd solution, and when you have 3 odds, that sum total will be odd. But there's an alternative solution where if you have 2 evens, that sum total so far is an even, but if you add a 3rd digit, which happens to be odd, that would mean that the sum total would be odd. So in both cases, well, to phrase it this way, one possibility is you have a solution that's all odd, and the other case is where you have 2 evens and an odd. And in both, you'll get a sum total of odd. All right, that said, let's go ahead and test criteria card E. Okay, so if you take a look at my proposal of 314, the Turing machine does not approve of it, but 314 falls under the category of no pairs. And so, but since the Turing machine does not approve of it, it's actually telling us that we do have a pair in our solution. So let's go ahead and type that up in our notes. And we'll say that the solution has a pair. Okay. And since it does have a pair, again, it could be a pair of evens or it could be a pair of odds. And obviously we do have at least one odd. So far we're thinking of it being potentially, again, a pair of evens or a pair of odds, and then that third digit would have to be odd. So it is interesting that we do have criteria card B telling us the number of ones. I do have a single one in the solution. We know we can't have 3 ones because we do have a pair, not 3 of a kind. So we could have a pair, or it could be a single one, or there could be no ones. So we have 3 possibilities in that scenario. And then we also have criteria card D, the adding of the first 2 digits. So I'm trying to think of, a possibility. I'm wondering if we do have an all odd solution, obviously, it's either going to have 2 5s or a single 5, 2 3s or a single 3, or 2 1s or a single 1, in some kind of combination. And I'm trying to anticipate what we could be looking for. So I don't think, let's see, could we have a sum of 6 for criteria card D, meaning that we have some 6s as a sum for triangle and square? I mean, you could have 1 5 or 5 1, but you could easily have 2 4 and 4 2 in there. I kind of like criteria card B, because if I do have a single 1, then that means that the other 2 digits are either 2 3s or 2 5s. So that's a possibility. And if there is no 1, then you'd have, either a pair of 3s or a pair of 5s, and then, the other digit 3 or 5. So that would be helpful too. I'm just trying to, I see a pro and con in that regard. And it could be that somehow, maybe, the sum is 6 and you have a single 1. So, I guess let me go ahead and see, if I had a sum of 6, I would test D automatically, but I don't. I'm just gonna go ahead and test criteria card B and hope for the best. Let's see. Okay, so it is not true that there's a single 1. So that means either we have no 1s or 2 1s. So let's go ahead and test, or type that up in our notes. And that is that the solution has 2 2 or no 1s. Okay, so we can't cross out anything, And yeah, so we're ending this round with no digits crossed off. And so yeah, we've completed this round. We did the 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. Okay, well, that no one, or at least, sorry, a single one is a bit informative in that we know that the sum then probably cannot be 6. Could it be? Maybe it still could be a 6. We just know it's not going to be a 1, 5. Actually, no, I take that back. The sum cannot be 6 because there's no way you could get, a sum of 6 with 1 or 5 because, well, let's see. Could you have, well, no, I take that back. I guess technically you still could get a sum of 6. It just means that criteria card A, the square, could be, the 1 or the 5. That's still, I guess, plausible. I guess the question is, if it is a 6 and there's a 1, how would you know what circle would be? You'd have an odd, but would it be a 1 or a 5? And there's really no indication of that. So even if you did have 2 5s or 2 1s, you wouldn't know how to pick. Sure, a square could tell you, well, it's a 1 or a 5. And we know it couldn't be 2 and 4 for 6 because you can't have 2 evens. Or no, wait. Oh, you would have to have a pair of evens. And so, yeah, 2 4 isn't going to be plausible. Okay, so yeah, so it can't be, I don't think it's going to be 6. So that means it's either going to be, something less than 6 or greater than 6. And we do have that criteria card where we have a 1. So it could be something like maybe 1 3 3. So how would that work? Again, circle. How would you decide which circle is? If we have a pair, or the only other thing I can think of is maybe it's 3 3 6, or sorry, 3 3 1, where we do have a 1, but we have a sum of 6. Could that be it? Square is 3, the sum is 6, forcing triangle to be 3, and then you do have a 1. That's plausible. Yeah, there may be too many possibilities where it's, the sum is less than 6 or greater than 6. I think I'm going to go with that. I'm going to go with 3 3 1. I mean, it could also be 3 3 5 and there be no 1s. That's possible. But I'm going to go with 3 3 1 and see what happens. Well, I'd be hedging. I don't think I'd be really hedging my bets. It'd be kind of hard to figure out whether square should be less than or greater than 3. Yeah. Okay, well, I'm going to take a risk. I'm going to say 3 3 1. Okay. So before I test the sum, I guess I really do want to test. Oh. I was just thinking, I guess I would have to retest criteria card B, the number of 1s. I guess it doesn't matter. Yeah. Let me go ahead and test criteria card A. Wow, it is a 3. I'm surprised. Okay. So we know square is exactly 3 since the Turing machine approves of my proposal. And so let's go ahead and type that up. So square is equal to 3. And so finally we get to cross out some digits. And so this will be interesting whether the sum is 6. I guess this will, let's see. So we have an odd and square. So the question is a 3 being paired up or is it by itself? Oh no! I just realized criteria card B told me there isn't a single 1. And I go ahead and choose a single 1 again. What a mistake. So I will not be able to test criteria card B again. Oh, what a mistake. Okay, well, let's go ahead and test criteria card D. Oh, wow, what a mistake. Okay, so the sum is not 6. So at least now, well, we can cross out the 3. Oh, goodness. Yeah, because triangle can't be 3 because that would give us a sum of 6. Okay. And we're basically done in this round because it's not worth it to test C or E. We know the sum has to be odd. And we know we have to have a pair. So, okay, so at least we know there's no pair of 3s because, well, oh no, I guess you could still have a pair of 3s. It could be 5, 3, 3. It couldn't be the evens. But at the same time, let's see. Well, okay, let's take a look at this. The only way we could have a pair of 1s is if it's triangle and circle. So if the sum, I guess if the sum were less than 6, your only choices would, well, no. Oh, that's interesting. That is interesting. So I don't think the sum, well, I guess the sum could be less than 6 and you have 2 1s. That's the only way to distinguish between 2, 3, 2 and 1, 3, 1. That's the only possibility. What about greater? Well, I don't think it's going to, that definitely is not going to happen because how would you distinguish between 4, 3, 4 and 5, 3, 5? There's no way to distinguish that because you are allowed a pair of either evens or odds. So yeah, it's not going to be greater. It has to be less because obviously it's not equal to. And oh, by the way, I guess I didn't type it up. So let's go ahead and say I'm going to deduce the sum of the first 2 digits will be less than. Wow, maybe this will, I can salvage this puzzle. So I'm going to deduce that the sum has to be I'm experiencing a bit of a lag. So, okay, so I'm saying that the sum is probably less than, and then we have two ones or not? Wow, that may be a big ask. This lag problem. I apologize. I'm not sure why it's behaving this way. Okay. And so yeah, so I'm deducing that the sum of the first two digits must indeed be less than 6. Because I can't distinguish between 434 and 535. There's nothing in our solution or in our set of criteria cards to help us do that. So it's going to be a quick third round where it's either going to be 131 or 232, and I'll be and as I stated, I'm deducing that the sum is less than. So I'm going to go to the next round, and I'm going to say 232, and I'm only going to test criteria card B again. So let's see. B. Okay, it is true that there are no ones. So the solution has no ones. Okay, so I'm going to cross out the ones. And again, I don't see how the sum could be greater than 6. So I'm going to say that the solution is 232. Oh, that's interesting. Yeah, because if you pick the 2 for triangle, you're forced to pick another even. And of course, it's got to be paired up, so it'd be 2. So yeah, so I'm saying that the solution should be 232. Well, if it turns out to be correct, I think I'd consider myself quite fortunate. Okay, so 232. Let's go verify. The only bad thing is I did have to go to a third round. That's the only unfortunate thing. Let's see. Okay, that is correct. But how do we do versus a Turing machine? I did 6 overall tests, but in 3 rounds. Not good, but we'll see. So first round we did B, C, E. And in the second round, we did the remaining 2, with A being the only correct one. So let's go ahead and type that up, BCE. So BCE, we're all incorrect. In the second round, we only tested A, which was correct. D was not. And we did do that B test, a number of ones, and that was also correct. So let's see. Yeah, unfortunately, even though we did do exactly 6 questions, the fact that I did it in 3 rounds means that the Turing machine did it more efficiently. It did it in 2 rounds. And let me see. Well, to be honest, to be honest, it was a bad second proposal. I should not have selected that one. Either I should have picked something that didn't have or had 2 ones, because then I could have tested B in the second round, and I'm pretty sure I would have gotten the same answer. So I could have picked something like 335, and I think I would have been able to deduce it. Okay, well, these errors do occur, careless as it was, but it does happen. So I'm just fortunate that I was able to recuperate. I was able to deduce criteria card D based on what I saw, and obviously I still got it correct, and did it in 6 questions, just 3 rounds. But okay, that's how it goes. Well, how did you solve it? I hope you did not commit the same mistake I did, but what did you do correctly? Share that in the comments. If you liked the video, obviously give it a thumbs up. And if you don't want to miss out on any future videos, hit subscribe to be notified. Well, until next time, have a great one.